Hello everyone. Today in this tutorial, we'll be training YOLOv9 model on custom dataset. For this purpose, we'll be using Google Colab. As we all know that Google Colab has free GPU limit for a particular period of time for each account, and we can use it for after some time. And right now, what I am using is this publicly available aquarium dataset for my training, which has these classes: fish, jellyfish, penguin, shark, puffin, stingray, starfish, and for each classes it has these amount of instances. So I'll be using this dataset for my training, and I am not directly using through API, but what I am doing is I have already downloaded it from the website, and I have uploaded it on my Google Drive because I want to use this dataset again and again for different purposes. So that's why I am accessing it through Google Drive. So for this purpose, if you want to use any dataset or any file which is available on Google Drive through Colab, so you need to mount your Colab with Google Drive. So for this purpose, you can use these two lines of code, that from google.colab import drive and the drive.mount content.drive, right? So you can just click it, and I have already mounted it, so it is showing me drive already mounted, right? But if not, it will ask you to just confirm everything and it will mount it. And this drive is the drive from my Google Drive. So in this way, we can access whatever data we have on our Google Drive from Colab. Yeah. Also, you can see here it's T4. What T4 means is that I'm using GPU. I'll show you. Okay. So right now you can see these are the 4 hardware accelerator. So I haven't used my free GPU for a couple of days, so it is available for me. So right now I'm using this. If I exceed the limit, which is free, like I'm using unpaid version, then I can only use CPU. So yes. So mounting is done to access data available on our Google Drive, and then we want to see that if we have the GPU, right? So we have the GPU like this one. So okay, this will make our training faster. Now, third thing is, I think most of the people know, but still just for the information to the person who doesn't know, that on Google Colab, if it disconnects or runtime disconnects, then whatever data we are saving, like suppose if we are training the model and our weights are being saved, right? Or we are uploading something from here directly on the Colab, right? So whenever something happens, any interruption in runtime or disconnection with the internet, this data which we are uploading directly here, it gets deleted, right? There is no way to get it back unless we haven't downloaded it before. So the best way is that just mount it to the working directory of the Google Drive. So like you can mount it, like I have given the path of, I have already created a folder in my OneDrive. I can show you this my drive and this YOLOv9, right? And whatever I am doing in this particular notebook, I want it to save inside that drive, so that if like by any chance it gets disconnected, then I do not lose those data. So just you can take any variable and put the path of the drive. So how can you do this? Just right click on this 3 arrow, then copy path and paste it here, right? And you can also check it by just saying it like whatever we are printing. So this is the path of the working directory. This means whatever we are running, everything will be saved inside that, which is present in my Google Drive, right? So we are ensuring that if anything happens by chance, we are not losing any data. And then after changing and importing the OS and setting the path, we can go inside this directory. Yeah, because right now we were there on the default path. Okay, so this was the process of ensuring that we are accessing Google Drive from Colab, and we are saving everything inside that working directory, not on the default path of the Colab, for ensuring of no data being lost. Now, the next step starts is cloning the YOLOv9 directory. That I have already done. Like I can show you inside the YOLOv9 folder. I have already cloned the YOLOv9 folder, so I won't do it again. You can just do it, git clone and this particular Git repository. And then what we can do is you can go inside this YOLOv9 directory, and then you need to install the requirements.txt file to ensure that you have all the versions on which this particular Git repository has been tested and run, right? So it's already done. I have already done it, so I'm just showing you. And then the next step would be to download the pre-trained weights. So what I will do is I will take the pre-trained weights and I'll retrain on my dataset using those pre-trained weights to get new weights. So these are the weights, right? So these are the gradient and other versions of YOLOv9. We are downloading all, and you can use any one of it, right? So, and also you can see I use wget, and I have provided this path. It's home means this particular path, and inside that I'm asking it to create directory weights and then save these files there. So I have already downloaded it. I can show you, like, this is the YOLOv9 home folder. Inside this is weights folder, and these are all the weights that have been already saved. You can also see by doing ls, these are all the weights which has been saved, right? Now this is the example of testing the pre-trained model. You can use any of the image, or you can upload it here, or you can download it from the internet, and you can just run it over it. Also using this python.detect command, detect.py file, and then weights, we can provide any of the above, and then confidence we can set it like whatever threshold you want to use, like 0.1, like 10%, 20, 30, 40. And then by source we can provide this image, video, or webcam, and this device, whether we want to use GPU, CPU, or what device, right? These things, like how we can access and test the pre-trained model on image, video, and webcam, I already discussed in my previous video. If you haven't watched it, please go and watch it. So we'll just move into the training part. So training, we are just ensuring that we are inside the home folder. That means the working directory, which is this YOLOv9. Inside this, you can see there is one train.py file. That means this one, right? We are gonna use this particular file, and we need to set these parameters: batch size, epochs. Like the number of batch size increases, you need more GPU power. So we need to set batch size, which ensures the compatibility with the GPU power we have available. The epochs, that is the number of steps we want to use. The image size, device, minimum items, closed mosaic, and weights. This configuration file, which is this gilan c.yaml, it is present inside this models detect folder. I can show you this: models detect, and then we have these YAML files. So we have YAML file which is there for each weight, right? So suppose if we want to use this gilan-c.pt, then we need to use gilan-c.yaml file, right? And we also want to use this other argument, which is another YAML file, which is hyperparameter.scratched-hi, which is present inside this data folder, hypes, and then we have this YAML file. So in YOLOv9, we need to use these parameters. There are few default options also. If you want to see, you can open this train.py file, and you can see that there are few default options available for each parameter. But if you want to change it for your own custom use case, you can change it. Like you can see here, these are the arguments. Okay, so these are the arguments available, that is weight, CFG, data, hyperparameter, epochs, and all these arguments, and they are these default values. If you want to change, you can change it and pass it while you're running it. If not, it will choose the default value available. So these are all the things we are using, and then we'll start the training, right? So when you are training, it will show you the CUDA version, PyTorch version it is using, the hyperparameters which is it is using. So right now it is using the default hyperparameters, and then it will show you the number of layers and the layers which is there in YOLOv9. So as we can see in this particular configuration for GLNC, we have 621 layers and these much number of parameters, and of course the gradient, we have these much number of gradients. And then it will show you first of all that it is checking all of the parameters, and then it performs albumtations, and then like albumtations is like it for augmentation. It adds few noises like suppose blurring and median blurring, conversion into gray, and different other options of editing it and then adding it. So by default it does it. You can also change it, but you need to set it externally. But right now we are just using the default parameters, and then it is using this train labels. So one thing I want to show you is that what is the most important thing is that is data path. So the data which we are using is the one which we have downloaded, right, which is there, which is this aquarium data set, right? So I have uploaded it inside my drive. It's not inside the YOLOv9 working directory, so I want to access it. So when you are providing the data path inside this hyphen data parameter, you need to give the YAML file path, right? So in how it is structured is, this is the dataset folder. When you will click, it has three folders: train folder, test folder, and valid folder, and one data.yaml file. Inside this train folder you have two folders: labels and images. It contains all the images, it contains all the txt files, it is label files for each images. Similarly, we have the image and labels folder for validation also, and for testing also we have images and labels folder. In the data.yaml file, what we do is we provide the path of images of for train, val, and test, which is this. So right now there is a basic structure that the dataset should be present inside the working directory, but I have changed it because I have put the dataset directory inside my home Google Drive. So what you need to do is you just put in the train and valid images path, that I mean this, like this. Just copy the path from here and then put it inside here. Similarly for val also, just copy the path of image, put it inside here. So if you're changing the structure of the default one, you need to change the YAML file also. That's the only thing you need to keep in mind. And you can see we have 7 number of classes, which are these, right? So while training we need to pass this YAML file path, right? So okay, so let's move ahead, and you can see the image size it is using is 640 for both training and validation. Also it is showing it will save the results inside this YOLOv9 runs train experiment 4. So this is the YOLOv9 folder, then we have the runs, and then we are training it, right? So there are three things: train, detect, and validate. So we are training it, and inside it is showing it will see the results inside this directory. So I have already trained it and I have used 25 epochs. So I won't do it now because it will take time, and I do not want to stretch the video too long, so I have already done it. As you can see, it is the 24th step. It starts with 0, so it will go to 24, so it is 25 steps, right? So you can see the GPU memory it is using, the box loss, the classification loss, the differentiation loss, and the instances, that means the number of classes present for the number of examples for each class is present, and this is the precision we have achieved, this is the recall we have achieved, this is the MAP we have achieved, right? So as you can see, after the completion of 25th step, we can see we have achieved 82% precision, 70% recall, and 80% MAP. So you can see that it has saved after the completion of all the epochs. And the weight inside this experiment 4, when we will open this folder, we can see there is one, there is one weights folder. So inside weights, it has saved like the best weights, like for each step it calculates the best step, so it saves the best step and also the last steps weight file. So we can use one of this, but the best way is to use the best.pt weight file, because it's the best on the model fields it is achieved during the training for any of the steps. So always use best.pt file. So yeah, just moving ahead, after that it has tested it on the validation, and you can see after the validation it is showing me the results it has achieved for all the 4 classes. Like we can see for this first class, we have achieved this precision, this much recall, this much MAP on 50%, this much MAP on 90%. Similarly, we can see the precision recall and MAP for each of the classes, right? Yeah, so all these results are saved inside this folder. There are different other results also which you can see. Suppose if you want to see the graphs of each, so inside the same folder you can see we have all these images that, like, you can see labels.jpg. If I open it, it's like it will show you how many examples of each classes we had, right? And similarly different other examples of plotting to analyze how the ratio of each classes are, right? And these are the examples of the results of the training. So this is the result.png. This is the way you can import these files, and you can see in the notebook, like using the IPython and giving the path. So this is, you can see this is the graph of the box loss, this is the graph of the classification loss. Similarly, graph of the precision recall. So generally loss graph of loss decreases and precision recall should increase, right? Also you can see this is the confusion matrix. It's also saved inside the same folder, this particular file. Here you can see through this thing the true positive and true negative. Suppose it means that this, for particular class fish, we achieved 83%, right? So but you can see from here that 83% fish it detected as fish, but 0.01% fish it detected as stingray. So confusion matrix, so you can see the true positive and false positive, or false negative and true negative. Like these analysis you can do it from the confusion matrix. Also while the model is validating, you can also visualize it. It is also saved inside this same results folder, that X4 experiment 4 for our case. These are the validations result. So there are 2-3 batch validation results. We are watching it once, so you can see the validation that it is doing almost fine, good. And there is a validation script also, which is present inside here, home and YOLOv9. And you need to just pass the same image size. You always ensure that whatever image size you have used during training, use the same image size during validation. Otherwise you won't get the good result. And the batch size, the confidence you want to threshold you want to use, the IOU, intersection over union, and the device. Also the YAML file. Of course, we want to use the same YAML file where we have provided the path of the validation dataset and the weights file. So right now what we want to do is, we are not using the pre-trained weight, but the weight of the model which we have saved, so which is here. So as we know that the result has been saved inside train, then experiment 4, and inside weights. So we have used the path, this path. So this is the path of our trained model, and we are validating it and visualizing it. So after validation, we can see we have got this result. So, and it has been saved inside YOLOv9 runs val and experiment. So YOLOv9 val and experiment. So these are the validation results. If you want to see, you can check any of it. Like if you want to see F1 score curve, you can see like this, or you can visualize it using IPython, but how we have done it before, like here. So using any of the way you can visualize it, but it's good to visualize and analyze the results for each classes. Like you can see this curve, it is showing you for each classes. Yeah, so we have done the training and visualization validation, and now we'll do the inference. So right now what we're doing is the dataset contained the parts for training, for validation and testing. So we are doing testing. So of course the image size should be same for training and validation, but you can change it for inference, right? So I'm providing the image size, I'm providing the confidence threshold, the device 0 default, and the weights file, which is the same best.pt, that is the weight file of the model we have trained, and the source. So source contain this path and this path. Yeah, so just put it there and then run it. So we have total 63 images. So it is performing inference on these images. You can see it is showing you 1 fish, 1 penguin, 1 shark, 19 penguins, and the time taken for detection, right? When we will go down, we can visualize the results. You can see it is saying results has been saved to YOLOv9 runs detecting experiment 4. So YOLOv9 runs detect and experiment 4. Yeah, so the results has been saved here. So yeah, so you can visualize it. So visualizing, we can use IPython, and we can glob it for all the JPGs present, and we can visualize it. You can whatever amount of images you want to see, like you can change it to 10, 20, 30. Right now I have set it to 10, so it will pick up 4 of the images and it will show me here. So as you can see, it is detecting as penguin, and you can see these are the small penguins also, but these are also being detected by YOLOv9. But as you can see, this is also penguin, but YOLOv9 is not able to detect. Probably if we will decrease the confidence, so it might detect that as well, but we want to keep it at least 25, so we won't increase it. Fish, so it's not that accurate. I mean, detection is almost accurate, but classification is not. This is fish, and like that. So you want to visualize how many number of example results you want to. Also, if you want to test on video, you can also test it. You can use same detect.py file, provide the weights file best.pt, and you can provide the source. So I have already uploaded a video in that drive, and then aquarium test.video, right? So I have provided the video path to it, and then I have tested it. So yeah, so when I have tested it, it is providing the results, like it reads the video by frame, and it is analyzing the each frame and performing it. So it converted, you can see, video into 3286 frame, right, by using a default FPS, and you can see these are the frames. It is not detecting anything, and then whatever it is detecting, like one jellyfish or one fish, it is showing it. And after completion of the detection of the video, you can see that it will save a resultant video, and it will show you the path of the video as well, on which the resultant video has been saved. So let me scroll, yeah. Okay, so after when all the 3286 frame has been checked, then again a resultant video has been saved inside YOLOv9 runs detecting experiment 5. So YOLOv9 this is the home directory, then this is the YOLOv9 directory which we have cloned, then runs, and then detect, because we are detecting and we have trained the detection model, and then experiment 5 because experiment 4 was for images and now for 5. So this is the resultant video which we have saved. So I think it would open it here. So I'll go to my OneDrive and I'll show you the result. So resultant video is like, we will go inside my drive. It was the YOLOv9, then YOLOv9, then runs, detect, experiment 5, and then this is the aquarium test video. Let's watch the video. So these were the, okay, so yeah, so this is the our resultant video, like the analysis inference of our trained model on this video. So this is the video which I have downloaded from the YouTube. It is not really related to the dataset that has been trained on, but a random video from the YouTube. So what we have done is we have trained our model and validated our model and tested our model on dataset which we have downloaded from the RoboFlow. But this video is not the one from the dataset, but it is the one which has been downloaded randomly from YouTube and then being tested on to actually analyze the result on real time or on a new dataset. So yeah, so this is the result. You can use any of the aquarium video or underwater video to analyze and test the result. Yeah, so I hope this information is clear and the steps are clear, how we can use the pre-trained weights of the YOLOv9 and how we can download and use the existing new dataset, and how we can access the Google Drive from Colab and use the dataset from the Colab and save the results for for the Colab you are using to train, and all the results to save inside the Google Drive. So how to change the working directory and the space. So basically how to make synchronization and mounting of the drive and Colab. So it's very important when you are using Colab to mount and ensure everything is being synchronized and saved in the Google Drive. So thank you so much for watching this video, and if it was helpful to you in any way, please do like, share and subscribe my YouTube channel if you haven't done already, and please also share reviews and whatever you want to watch in the next tutorial. Yeah, thank you so much.